Welcome to the Crazy Hat Chemist. So another video and solutions, and boy do I have a solution for you here today. Bam! So today we're talking about boiling point elevation calculation number 2. Okay, so this one is how much sodium chloride in grams must be added to 8.0 quarts of water to have a boiling point of 102.5 degrees Celsius. And I have that conversion of quarts to milliliters. That's 1 quart is equal to 946 milliliters there, right there for you. Okay, the boiling point of the solution is equal to the boiling point normal, that is the normal boiling point of the solvent, plus the change in temperature of the boiling point for that solution. So let's figure out what values we have. We know that the solute is the sodium chloride. We know that solvent is the water. So what is the normal boiling point for the solvent? Okay, and that is the water, that's 100, and we know the boiling point of that solution, that's the 102.5. So I'm going to plug those in there, and I'm going to solve for what I am missing. And that is the change in temperature of the boiling point. So you see that I have the 102.5 for the boiling point of the solution. The normal boiling point of water, that's plugged in there at 100. I'm going to solve for the change in temperature of the boiling point, and that is 2.5 degrees Celsius. Now, what is the change in temperature of the boiling point? That also has an equation that is equal to Kim. So that 2.5 degrees Celsius is the change in temperature of the boiling point. Okay, we're going to have to get the constant for the boiling point. We've used that already before in the previous problem. And then we're going to have to get the I, that is the Van't Hoff factor for the solute, and that is sodium chloride in this example. And then we're going to have to solve for the molality here. So the Van't Hoff factor is based on the solute, and that is sodium chloride. So how many cations are there? How many anions are there? Because this is an ionic compound. There's one cation, that's the sodium ion. There's one anion, that's the chloride ion. I'm going to sum those two numbers up, and that's a 2. So the Van't Hoff factor for sodium chloride is a 2. That's the I of 2. It's actually, if you look it up in the Handbook of Chemistry and Physics, is a value of 1.9. But we're going to be using 2 right here because we're not actually having that textbook with us or that reference book with us at the moment. Okay, the constant was given in the previous problem, so that's why it's 0.512 degrees Celsius per molality. I'm solving for the molality. Okay, you should see that you're just going to rearrange this here, and we get 2.4 molal for the molality. Okay, now what we need to do is we need to use that molality equation. Okay, and we're going to convert the quarts into milliliters with the unit conversion that I've given. Then using the density of water, that's 1 gram per 1 milliliter. Okay, that's an assumed density if nothing else is given. And then I'm going to convert those grams into kilograms. 1 kilogram is equal to 1,000 grams. So 8 quarts is equal to 7.6 kilograms of water. That molality equation is right here. So the molality is equal to the moles of the solute, that's the sodium chloride, divided by the kilograms of solvent. Now, in the 2.4 molality, I just solved for the molality. So that's in the lower left-hand corner. That's going to go right here. And I've also solved for the 7.6 kilograms of the water, which is the kilograms of the solvent. That's going to go right down there. And I'm going to be solving for the moles of the solute. The moles of the solute are the sodium chloride. Okay, hopefully that's okay for you so far. I'm going to plug those numbers in right here. I got 2.4 molal is equal to X number of moles of sodium chloride divided by the 7.6 kilograms of water. Rearranging this and solving for the moles of sodium chloride, I got 18 moles of sodium chloride. Now the problem is asking me how much mass is it. Now, so I'm going to take this 18 moles of sodium chloride using the molar mass of sodium chloride, and then obtain the mass of sodium chloride in 18 moles of sodium chloride, and here is my number. That's 1.1 times 10 to the 3 grams of sodium chloride is my answer for this problem. So that means if I have 8 quarts of water, I need to add 1.1 times 10 to the 3 grams of sodium chloride to make the boiling point of that solution 102.5 degrees Celsius. Hopefully that makes sense for you. You can actually do this if you want to maybe hike at elevation. This is a great way. If you want to hike at elevation, you want to either use a pressure cooker, which is pretty difficult to carry with you, or you can add sodium chloride to that water and increase the boiling point. Because as you go up in elevation, there is less pressure, that is atmospheric pressure, okay? And then therefore the water at elevation will boil at a lower temperature. In order for you to cook at a higher temperature, you could add sodium chloride to that water, and then it will cook at a higher temperature. And you can do the calculation on that with knowing the normal boiling point at elevation of which you are traveling to. It's an excellent application of a colligative property in the unit of solutions. Super cool application. Okay, I am the Crazy Hat Chemist, and I got a crazy hat here for you. It is the Perfect Pumpkin Hat. If you like that video, give me a thumbs up, subscribe to my YouTube channel, and you can always get yourself a perfect pumpkin hat too. Okay, have a fantastic day, and I'm going to see you next time. Bye now.